introduction to what? To unsupervised machine learning, right?
Yes.
So just be checking what I have on my screen. I think we cover all this. Whatever here, we discuss this as well. Have we discussed this
Yes.
particular slide? You said yes.
No, we've not started this one.
No, we're not going to here. Let me see. I think this is, let me just go back to the folder. Check this one. Okay, so I think we're on this set of slides where we started the introduction to data science. We discussed this, and I've also explained all this to go for this section. So just be checking the slide. We'll discuss this as well. We have also discussed the skill sets the data scientists should have. We have discussed this, right?
Yes.
Supervised learning and unsupervised learning. So make sure that you are making your notes so that in subsequent classes you know where we stop. Then we will also talk about the common algorithm used in both supervised and unsupervised learning. We discussed this. Then we'll also talk about the data science workflow, where I explain all these as different phases you have to go through as a data scientist under unsupervised. And remember, I told us that they are not sequential, which means that there are times you explore your data before you clean the data. There are times you clean the data before you start your model. That's what these arrows are indicating. And this is where we started looking at them one after the other, started discussing what is scoping a project in data science. Talk about this also, gathering data. Just be following once you get to the one you feel we have not done, so I can start. Have we covered this as well, or this is where we are?
We finished all this one. I think we got to even 6, 7.
Okay, what we were actually doing was a kind of repetition of some of the things we've done in the class while we were still attending the NIT class, right? So I only captured them because of in case someone else joined us. Okay, so let's quickly look at unsupervised learning. I don't think we have done this. We have not really focused on unsupervised learning, have we?
No. We're supposed to start there today.
Okay, so let's look at that unsupervised learning. So unsupervised learning is used to discover pattern and relationship within data. Remember, I told us that in machine learning there are two arms. We have the supervised learning, and then we also have the unsupervised learning, where I told us that the supervised learning focus on building and testing model for predictive analytics, while the unsupervised focuses on segmenting, grouping data, clustering data. You understand? In order for us to perfect them, which I also said that the unsupervised learning falls under data cleaning, because that is where you learn how to engineer the entire data given to you for you to be able to perfect it before passing it into a predictive analytics model. And don't forget, I also said that we spend 80% of our time in perfecting our data in machine learning. Then we just spend 20% because once we have perfected the data, the model will be the one to do the analytics. And that is why we are learning these different models on how to design them. So, but the focus of the unsupervised, like I've highlighted here, is on discovering patterns and relationship within the data. And this discovering will be achieved through studying the behavior or through clustering data sets based on certain attribute or behavior. So like I said here, these techniques can be utilized during the cleaning, exploratory, or modeling phase of the data science workflow. And all findings can be shared as insights. So while you are identifying patterns and discovering relationship between your given data variables, you will also get to a point where you have discovered some insights which can also be shared alongside. So what is the takeaway here for the unsupervised, everything we have done so far? Just trying to recap it. So we should always know that data science is about using data to make smart decisions, whether it is machine learning, whether it is data analysis. We should bear it at the back of our mind that we did with, data science is about using data to make smart decisions. So the supervised learning techniques use historical data. That is one thing we have learned, that under supervised, we use historical data to predict the future. And under unsupervised learning, we use techniques. Supervised learning techniques use algorithms to find patterns and relations. So we should always know that is one of the takeaways from what we have explained so far. Now, data scientists have both coding and math skill along with domain expertise. We should always bear that at the back of our mind, that data scientists have both coding and mathematics skills. For you to be a sound data scientist, it is expected that you have at least coding skill. That is why we are learning this program with Python, which is a programming language. What makes you a programmer? Because a programmer, it is because you write code. So in addition to technical expertise, soft skills like communication, problem solving, curiosity, creativity, Greeks, and Googling prowess round out the data scientist skill set. So all these are things we have already highlighted. That's part of skill set the data scientist should have. Then we also, another takeaway is that we find out that data science workflow starts with defining a clear scope. So that one is also pointed out in the course of the last class training. We have also learned that unsupervised learning techniques are used for finding patterns in data. Data scientists are often tasked with finding patterns and relationships in data. So it's one of the major tasks that you should be expecting. Just like that analysis I gave, you spend 80% of your time perfecting the data, which is restructuring the data to fit into analytics model. Because it is not every data structure can actually be imputed into a predictive analytics model. So it becomes your responsibility to perfect it. Sometimes you have to re-engineer some feature. At some point, you have to do selection. You have to weigh the headers and drop some. And at some point, you have to convert all data to what? To make sure that you don't have a null and that all the values across all headers are numeric. All of this is to ensure that the data is perfected to be passed into analytics model. So that is one thing we have learned. Then unsupervised learning 101. So this is where we want to actually start it properly. So what we have been doing since, just like we are explaining, just like giving you a background. Now we want to start it properly. So, and I've highlighted that in this session, we will cover the basics of unsupervised learning, including key concepts, techniques, and applications, and where it can be used within the data science workflow. So that shall be our focus. So topics we will cover here, we will look at unsupervised learning, techniques, and applications. We will also look at data science workflow. So here, I think, okay, so this is a more explanatory diagram that is highlighting the concept around supervised learning and the concept around unsupervised learning. So if you look at the diagram under supervised learning, there is a keyword that is used there which has a label. A label is just like the headers. That is a label. We have we like call that label identifier. We can also actually call it identifier. So under unsupervised learning, you can see the keyword used there does not have a label. Does not have a label. So as we proceed, you get to know what we mean by having a label and what we mean by not having a label. Like you see the further breakdown here, just for us to understand the kind of activities that happen under each of these techniques for machine learning. We have regression and then we have classification. So under regression, that is where you use to predict value for numerical variables, while classification used to predict labels for categorical variables. Categorical variables could be maybe a heading. Let me use that common data we have been working with, which is that salary payroll. Here we have department. Under department, we have different types of departments that stand as the unique departments. I think we have about 9 to 8 of them, or 8 to 9 of them. So they are categorical data because they can be grouped in different categories. So that is why it is referred to as classification, because you are going to say, okay, this one is this class, that one is that class. That is the meaning. So all of this falls under supervised learning. Now, regression is just like we are dealing with continuous, data. While classification, it might not really be continuous data. So if you look at the explanation under the unsupervised learning, you will clearly see that I said used to describe or organize data in some non-obvious way. So the unsupervised actually focus on reorganizing your data, preparing your data for it to be suitable to pass into analytics model. That is what we are saying. Now look at the proper understanding. You can see this is the full demonstration of the unsupervised learning. Remember from the beginning, we said that the unsupervised learning focuses on segmenting data, grouping data, clustering your data. And this clustering will be achieved due to measuring the distance between one and the other, or the behavior of your data variables. That is what will determine whether you are to cluster this, because the clustering in this case is just like, let me use your business as an example. For example, you have customers, let's say you sell 3 different products. You sell a CPU, you sell laptop, you sell flash drive, for example. And then you are, as your customers are buying these products, you are busy storing them in a data system. So the ones that are buying mouse, the ones that are buying flash drive, you are recording them in the same data system. The ones that are buying laptop, you are also recording them. So at some point, you will find out that some persons are buying one particular product than the other. That is you identifying the behavior of the customers. You have used the mode of transaction, mode of the products they purchase to now be able to know their behavior. So when you notice that, you can cluster those ones that purchase, those ones that you have found out that they like, or they are fond of buying mouse, or they buy mouse than every other device. You can cluster them. Now look at the diagram here. So this diagram is a data set that was collected from a movie website, where the website, the company have been able to study the behavior of the movie viewers. And if you look at this here, we have customer. So the customer header here is the identifier. Names are not repeated. Now, if you check here, if you check the two last column, which I highlighted, these are feature, what goes into the model. The first one is giving us analysis of people who like streaming movies, as it's been titled there, music streaming hours. Second one is podcast listening hour. So these are two different programs the television station or the media house organizes, and they discover after some time, like as you are seeing there with the clustering, with the highlighting here. So this set of people, they are in they are labeled movie or music lovers. What makes them music lover? You will find out that, let's look at them under music streaming hour. Look at, they have the highest value, 46, 38, then 44. So that is why we say that, okay, this set of people, they love music. So we cluster them and we name that cluster as cluster 1. Now, we look at the next set of people here. Here, they drop under what? Music here, they drop, but here they increase under podcast listening. They are doing better than this set of people. So we now group them as cluster 2 and name them what? Podcast what? Enthusiasts. Then this set of people, comparing them with these two other clusters, they are not doing well. If you compare them to this one, they are not doing well. If you compare them to this one, they are not doing well. Look at their values under both headers are low. That is why we classify them as casual listener. So if this happen to be a business, and you have a cluster that shows that a customer does not purchase that product that much, you are not going to waste your time investing your resources on that. That is after you have assessed everything about those products, whether maybe they are not well marketed, or maybe the same concentration of marketing was given to them, but yet they have a very low sales on them. So that is what you are trying to help your data scientist or whoever is going to pass this data into analysis model. You are trying to help the machine by grouping them first, because when they are not grouped, it will be difficult for the machine to perform predictive analysis, which is the focus of data science. Now, here I give you additional that what note, instead of predicting something, we are only trying to put rows together. That is what we are doing under unsupervised learning. I hope you are following.
Yes, I'm following.
Okay. Is this explanation clear to you with the picture?
Yes, yes, I understand the picture.
Okay. So the question we should be asking here is what? How can we segment what? This customer. That is what we are doing here. Because here we are clustering customer based on listening behavior. So this is just like an example so that you have a clear picture of what unsupervised is targeting. Now, that same table that I show you with those clusters is what I have visualized here. All these are practical things we are going to do. But I'm only trying to give you a pictorial representation of what we are going to exploit Python functions to achieve. Because all this like this clustering now, we are not going to use our hand today. We are going to be deploying functions and libraries for us to cluster, to send those functions to data set to help us do the clustering. And then once that clustering is done, we can now visualize it so that we can conceptualize it, so that we can see the reality of what we are seeing. Because when you present your findings with graphical model, you have a clearer picture of what you are talking. Now you can see it here now. These are the three clusters that we have there. And these are the legends. The legends help us to interpret our visualizations. With this color, these are the music lover. You can see them in one cluster, in one group, in one segment. And then you can see podcast enthusiasts in another word. So how do I know which one of these represented? Using the legend, the color. So these are them. And then this casual, these are the people here. And there's a graph of music streaming hour against what? Podcast listening what? Hour. So let's quickly go to unsupervised learning techniques, since we have established that foundation. So there are different techniques. These techniques specify how do you intend to achieve all these that we are talking about, since you are going to use some logic. This logic are referred to as the techniques. So these techniques are the reason why you register, so that you know the technical application of this function for you to get your data ready for analysis. So there are two popular categories of unsupervised learning techniques you must know. In as much unsupervised is concerned, always know that there are two of them. The first one is the clustering, and the second one is dimensionality reduction. So from what we have explained so far, you cannot see where we are navigating towards. Because we say that unsupervised has to do with reorganizing your data, grouping the data. So the process of preparing your data, reorganizing it, is either you are applying clustering techniques, or you are also reducing the dimension of the data frame. So let's look at the brief explanation under each of them. So identifying groups or clusters of data points that are similar to one another but distinct from another group. So if you look at the picture, the graph I just showed you now, those people that are in one cluster, they are similar to themselves, but they are distinct. In other words, they are different from other clusters. That is what clustering is all about. So what are the common techniques we are going to deploy to achieve that? We are going to use K-means clustering. That K-means is a library, just like the way you have pandas, which we are going to import and then be accessing some functions from it. So we are going to bring it as a bucket of function in which we can access those functions for clustering, for having those grouping that we just saw now. So we are also going to use hierarchical clustering, and we are going to use what? DB scan, density-based clustering. So all these are library. All these that you are seeing here, they are library, just like the way you import pandas. So we are going to be importing library called K-means, hierarchical, and the rest of them. And these are the techniques. They fall under the techniques you are going to deploy. So when you claim you are a data scientist, that must have gone through either supervised learning or unsupervised, particularly if it is under unsupervised. It is expected that you have an idea of the techniques you use in deriving your insight or in structuring your data. So what are the applications? The application is clustering / what? Segmentation, anomaly detection, recommenders. All these, they are techniques. We're going to see them practically. So these are actually what will be taking us time, up to like that 2 to 3 months, because we'll be learning all these models, all these libraries, how to deploy them, different techniques involved around them. So let's look at dimensionality reduction. What does that mean in data science? Reducing the number of columns or dimensions. It is called dimensionality what? Deduction, which falls under one of the techniques applied in what? Unsupervised learning for segmenting data, for reorganizing data, for clustering data. So in a data set rather, while losing a little information as possible. So even as we are going to be reducing, for example, now we are going to be reducing the height, the length, the width of our data, and sometimes increasing, we will reduce the height of our data and increasing the width, because these are the best practice to be passed into a model. So that is what dimensionality reduction means. So you can be given a data set where you as a data scientist, you will engage unsupervised learning for you to be able to what? To customize the data, to reduce its volume. And mind you, in the process of doing that, yes, you might be losing some information, but those information you are losing will gear you towards perfecting the data for your analysis. So common techniques here, we are going to use PCA, which means principal component analysis. We are going to use TSLE. That is what the T short stand for: stochastic neighbor embedding. We have SVD, which means singular value decomposition. All these, by the time we have applied them practically, they are very simple to understand. So what are the applications here? We're going to be doing feature extraction. The word feature in data science, it means headings, the columns in your data set. So here in data science, anytime I use the word feature, just when I'm talking about what? The label, the description of your data object. We are going to also use data visualization and then also recommender. So you can see that recommender is common on both unsupervised learning techniques, both in clustering, you have it, both here, you have it. Okay, so let's quickly talk about this application, that is unsupervised learning applications, since we talk about unsupervised learning techniques. There are two common applications of unsupervised learning techniques: anomaly detection, identifying rare points in a data set that deviates significantly from the rest. That is called anomaly detection. So you need to be familiar with these terms, because sometimes when you go for an interview, they will throw them on you, because every field has its own terminologies, which as you are learning that field, it is part of your responsibility to get used to those terms. Everything we are doing right now look like we are blowing grammar, but this foundation, it is very, very recommended. By the time we get to the practical now, you see how all this will be surfacing. So if you have not taken time to understand them, then the whole thing will look very cumbersome to you. So unsupervised, so you know what anomaly detection is. Then we have recommender, which is one of the applications we mentioned there, which I said is common to both clustering and what? Dimensionality reduction. So suggesting items to users based on their preferences or behavior, like the explanation I gave before. Because we are doing predictive analysis, which means that what we are talking about the future. And you are saying that this is what they should do concerning the future. So based on what factor you are going to make that recommendation, that is recommender. You are going to be suggesting items to user based on their preferences or behavior. I've explained that before. The reoccurrence, that is what the machine uses. So that is why if you train, let's say you pass a particular data set to the machine, and you train the machine, which is supervised now, you train the machine to understand that data so that it can be used for the machine itself to perform the predictive analysis. The machine is going to be looking at the reoccurrence of those variables, those values in the data. That is the basis is going to use to tell you that, okay, this is what This is the kind of movie people would like to watch tomorrow based on the reoccurrence of a certain movie that they are watching today. So that is why it's precise. There is no emotion there. The actual value, how does it reoccur within the data, is what the machine looks at to predict. It's not human being that maybe based on the state of their mind, they can just assume. So that is what we're talking about here. So unsupervised learning techniques, clustering techniques, dimensionality, reduction techniques, then other techniques under each of them. Here we have statistical analysis, time series analysis. Here we have distance measure. That is how you're going to know how is this one deviate, how is it close to this one? What's the distance between this occurrence and the other one? That these are the factors you are going to use. So let's look at the structure of this course. The structure, the way we are going to take it. So we will cover unsupervised learning techniques and application in this order. We are going to look at under the category, we have the unsupervised learning techniques, we have the applications. So the first category is this, which is clustering. And under clustering that we have the KV clustering, hierarchical clustering, DB-scan clustering, and then we have isolation forest. That one is in between the two categories. And that is where we also have our what? Anomality what? Detection, which is the point at which one variable is deviating from the other. So dimensionality reduction. These are also what the order, the PCA, which I talked about, and thereof. And then we have recommender, like we had it there. We have it repeated in both, which means that it's very important. Both techniques apply what? Recommender. Okay, so unsupervised learning workflow. Now here we are looking at what? Data prep. So practically this is how we are going to be going. We are going to start with data preparation, and then we'll be deploying so many, these are the things we'll be doing. We will get your data ready to impute into what? A model. And how we are going to do that, we are going to single table, we're going to make sure that all the values are null, which means that what? No missing value. We are going to make sure that all the values are converted to numbers, integer. We are going to select feature. We are going to do feature engineering, which means that we are going to regenerate some headings from the data in order for us to get what we are going to be selecting feature. We are going to be scaling. That scaling means we are going to be weighing how important this column is, then we pick it. The ones that are not important, we drop them. That is the dimensional what the reduction talking about. So we are going to also work with what? Algorithm. Under algorithm, we are going to be applying an unsupervised learning what technique, such as clustering, dimensionality, reduction. Tuning, we are going to enhance, we are going to improve, evaluate, and tune the model using metric and what? Intuitions. So here we are going to employ what we call what? Metrics inertia. All these are practical. We are going to visualize our data. We are going to interpret our results at the end of the day. Then selection. Pick the best results and identify any insights. Like I told you, we are going to, after everything, so okay, which one is the best result? Let's pick this. Let us not pick that. Then note, the main difference compared to supervised learning are the lack of data splitting, having training and testing sets, and the focus on evaluation based on what? Intuition. So in supervised, we are going to be training data and testing data. But here we are not training data. We are only grouping, clustering, segmenting, cleaning the data so that it can be passed into such a model that will be used to train the data in the machine and also to test before using it for prediction. So this is unsupervised learning workflow. Also, here we talk about, we are breaking some of those techniques or the application. We are breaking them from each of this workflow. So you can see where you have anomaly detection is under data cleaning, where we are going to use the PCA techniques, and the TSD is under what? Exploring data. Where we are going to use the principal, the PCA is what? The model. So you can see where all these are actually derived from. Like this one now, You see that all of them, they are from what? Modeling. All of this we're going to start with, they fall under modeling. Then by the time we get here, we will now be involving. So you can see why I said they are not sequential. Hope it's clear to you, sir. Are you following? If you can unmute yourself and respond.
I'm following. I'm
Okay, good.
following.
Okay. So so this is still the explanation I was giving. Now the key takeaway here is unsupervised learning is used to find pattern and whatever. Now we go to data preparation. So here we are entering the practical aspects. So as you can see here, like we specified there as the way we are going to go, we're going to start with preparing our model. So in this section, we will review the data prep steps required before applying unsupervised learning algorithms, including making sure the rows and the column are set up properly. How do you achieve that? That is data cleaning. So that is the focus of this. So everything in this section is on data preparation before you pass such a data to analysis what model. So topics we shall cover here, we will look at data prep steps, we will look at row granularity. This is a special thing which you get to know what it is. We also look at column preparation, we look at features engineering, we look at feature selection and feature scaling. What is our goal for this section? We'll learn Python techniques to adjust rows granularity. That's what? Reducing or increasing the number of rows. We will also learn Python to apply features engineering techniques for unsupervised learning model. We also learn Python on how to understand why identifier column should be excluded from modeling but used as reference. Identifier columns are like the name of the customer because they are unique. They used to identify. So we don't want them. Sometimes we will remove them, but we will represent them with another variable. So identify a situation where feature scaling is needed. We will also identify that. It's part of what we are going to learn here. So right now, we will now go to what? Let's go to Python notebook for application. So let me just explain it. So you go to Python, help me to snap this because you will open a project now in Python and write this code. That is the practical we are doing today. Are you with me? So you are going to replicate this. This is like a dictionary. This is a dictionary. Remember we did something under the Python multi-structure data type where we dealt with lists. You should remember set, dictionary, tuple. So this is a dictionary. So we are going to use this as a simple data. So the result of this is what we are getting here. So this is the data we will now start preparing. So no, students are to replicate. So snap it, create a folder, name it data science masterclass, then call it in your notebook. So that is what I want to quickly do now. So I think I've created one before. Let me see. So I expect you. I hope you have snapped that. Have you snapped it so that I
Already
can?
screenshotted.
Okay, good.
Yes.
So just start coding, start replicating it. So let me be doing mine as well, so that we can be on the same page. Okay. Hope you are doing that.
Yes.
I think I've done mine because I copied from one of my existing. So are you with me? Have you written your, or you are still writing?
I'm still writing.
Okay, so just hold on. Let me just explain the practical I want also you can take your time to achieve that for the next slide. Now, if you look at this is the data you are about to compute, and this is the output. This is the output. Now I have a sheet or a cell where I have already implemented all this. So I just want to use to explain. Now, let's look at, if you go back to our slide now, if we go back to our slides, where are we? I think somewhere here. There's some things I just want us to know before. Now, this is where I'm talking about. Okay, this was the, okay, so this is the data modeling slide, like what we're about to do now. So these are the steps we are expected towards to go through. We are going to start with setting the correct row granularity. Then we'll also look at ensuring each column is null and numeric, which means that no missing value and they are all numbers. We also do what we call feature engineering, which I've already highlighted for modeling, selecting feature. Now, this is what I want us to do now. I want to look at this data. If you look at the data, you will see that this is the original data given to you that is capturing different types of songs people listen to in this movie industry, for example, or in a website where you upload video or audio, whatever it is. So we have song, we have genre. This is where you record different types of song. Now, aria is repeated. So let me just explain it from here so that you understand. So to set the correct row granularity, think about the question you are trying to answer and determine which one or what one row observation of your table will look like. That's what we are trying to explain here. So you can see we reduce, look at the length of this. Area. So there is no point of this, since it's the same person. So the whole of one as in this area is represented once here. And that has helped us to reduce the height of this data and also increase the length. So what has happened here now is a typical example of the row granularity. That is a process of either reducing the height and increasing what? The width of your data. Now, there are functions you use to achieve that. So if you check this explanation here, I said this table has the correct data, but it needs to be reshaped so that each row represents one customer. That's what we are doing here. Because on this table here, each row is not representing one customer. You can see just one customer represented by 1, 2, 3. This is unnecessary, populating the table. That is what we have been able to use our data prep skill as unsupervised learner to be able to what? To reduce it so that it can be best passed into our predictive analytics model. So if you now come here now, this is where we are reshaping the data. And I said common ways to reshape data to the correct row granularity are using .group is a function to combine all records with the same ID column into a single row. So this is that data that you are about to compute. So this is the function I'm about to use. Look at the way we applied it now. We open this bracket and then we pass in the name of the data. We concatenated the function, the group, and then this is the customer. This is where you are capturing all the customers, as in one customer should be represented. This is where you are capturing what the song they listen to. Now, if you still remember, we are concatenating this sum function in order to help us summarize it. And then reset underscore index is to give us the numbering in proper order. Then I said in data analysis with Python, particularly using pandas, the method .reset index is used to reset the index of a data frame back to the default integer index, which is what we have derived here. So if you look at it here, so I said we have .group, we have what? .pivot. So if I go back to my data set now, which is the practical I really want us to do. So if I come back here now, I have already prepared it in one. This is the function. So I will just take the whole of this. I'll just take the whole of this, Control C, then go back to where we are. So it's expected that you must have completed that data entry, and then you must have gotten this result. Now we want to now shape it. We want to reshape it in a way that each row will be represented what? By each customer. That is when you need this particular code. So use group by to sum up the songs for each customer. So if I run this now, you see what we have now. So this is exactly what I was showing you in that slide. Is that clear?
Yes, I understand.
Good. So now, so that is one thing. Now, if you go back to the slide again, you will see that there is something we need to also notice under reshaping. So this is using the second method. I said there are two ways we use in reshaping our data. Either we use the .group by or we use the pivot. So if I go back here now to show you, let me see if I actually apply that option in that prepare slide. Cell. So this is it. This is where I applied the .pivot. It's the same result we are going to get. So it's now left for you to consider whether you want to achieve it with .group by or you want to achieve it with .pivot. So if I bring it here now, so make sure that I will send you the video so that you can watch it and perform all this. So you can see that as you restructured this with dot pivot, what do you get? You can see that the structure is different from what you got when you use this. So what is happening here is because we have to add dot what? Dot reset, right? Are you with me? Dot reset underscore
Yes, I'm with you.
index. We have to add this. So if I run it now, you can see that I have the proper what? Number. But with this, I have NaN. So if I want to remove this NaN, now that is what I'm trying to explain here. You want to remove the NaN, you are going to add this dot fill now, which is part of what we have to cover in our basic analysis with Python, in order to replace all the missing values with a constant value such as 0. So what I'm going to do is to come here. I can just bring it before this and then do what? Dot fill now. Do dot fill now and then supply 0. So what is it saying? Value index. So I think I should bring it here. So put a comma here. Dot fill. So let me take this one down. Okay, let me just confirm what I have here. Okay, so I have seen where the error is coming from. So I'm supposed to put this comma. What's it? Or maybe one of the okay. I'm trying to find out exactly what is not syntax error. We have to close. Let me see what I have. So we have it here. We have it here. Just also have to be checking. There's a place where probably